Okay, we're going to plot some vectors here, and so what we need to do is we need to identify the points and plot the points first, and then the vector will run through them, because vectors have a distance, or in this case a length, and a direction. So it's got a scalar and a direction. So plot the vector through the point 5, 4. So remember, this is x, y. So that's pretty easy on our Cartesian or rectangular coordinates. We're going 5. So 1, 2, 3, 4, 5, and then 4. 1, 2, 3, 4. So our point is going to be right there, okay? And then we need to plot it as a vector. So it's going to be a line coming through here, and we'll put the arrows on it like that, heading in that direction, okay? And that was our point A right there, and that was our vector, okay? And now we want to convert this to polar, and we want to plot it, okay? Well, we're going to plot it onto here. What we need to know is we need to know what this angle is right here, okay? And so in order to get this angle right here, and we want to get the Cartesians here, we know that the x here was 5, 1, 2, 3, 4, 5, and then the y here was 4. So we have 4 here and 5 here. So what is this angle? Well, we're going to use our trigonometry, which is SOHCAHTOA, and because we're talking about polars, and we see that we have the opposite and the adjacent. Opposite, we're going to use tan. So we're going to go tan of theta is equal to the opposite over the adjacent. That's what we've got. So we take the opposite of this, we've got 4, and for the adjacent, we've got 5. But we want the angle, so we need to take the inverse function of that. So we're going to take this, and we're going to go 4 divided by 5 equals, and we're going to do inverse tan, and that equals 38.66 degrees. All right, so that's what this is right here. 38.66 degrees. So now we've got our angle here. So this is heading off somewhere here between 30 and 60 degrees, all right? But we do need the magnitude of this, and that's what's shown here by the hypotenuse, all right? So we could use trig to get the hypotenuse, sine or cosine, but maybe we should just use the Pythagoras theorems, because we know that c squared equals a squared plus b squared, okay? And that's Pythagoras. So we want c squared equal to 4 squared plus 5 squared. And what do we need to do? We need to take the square root of each side here so that we can get rid of the square on this side. So c is equal to the square root of, well, this is 16 and this is 25. So we got the square root of 16 and 25 is 41. Well, if I take 41 and I square root it, I get 6.40. So this side right here is 6.4. That's our hypotenuse. So the length of our vector is 6.4 and the angle is 38.6 degrees. So if I come here and I plot it, I've got 30, that's probably 40, 50, 60. So I'm not quite here, and I'm going, so it's going to be kind of be along this line right here. I'll draw it lightly, and I'm going out 6.4 units. So 1, 2, 3, 4, 5, 6, and about half. So there's my point there, and if I draw it onto there like that, I have 6.4 at an angle of 38.66 degrees, and that would be my point A there, okay? So 6.4 units at an angle of 38.66. So there I have my vector, and I put it as rectangular, and there it is, angular. We've got another one to do right here. This one is the point, it says 5 at an angle of negative 480 degrees. So let's start by plotting that. 5 at an angle of negative 480 degrees. So, well, we're starting here at 0, and we're going negative 480, which is going to be all the way around the circle at least once, because that's 360. So if we take 360 away from here, we can see that we're going to have to go a negative 360, and then we're going to have to do a negative 120 degrees more, because those two would add up to 480 degrees. So if we started here, we would go, what's my angle at 5? So it's going to be negative 360 and negative 120. So once I go 360, here's 30, 60, 90, 120. I'm actually going to end up on this line here, but we'd be talking about going, around, all the way around once, and then coming around to here, okay? Because we have to do a full negative 360, and then we have to add 30, 60, 90, 120 more, all right? And so it would be 5, so we go 1, 2, 3, 4, 5, and so that point would be right there. I think we called it point B, and so that's where 5 at an angle of negative 480 degrees is. It's right there. Be aware that we had to go all the way around the circle once and then do 120 degrees more to get to the 480. Now, when we go to plot this, we have to take a look and see what's going on with our triangle right here. So if I take a look at this triangle, and I kind of, I'm going to plot it here before I transfer it up there. It's going to be, this point's going to be sitting out here somewhere, this B, and I just kind of transposed this triangle here. I just kind of transpose that down to here so that I can work some math on it. We know that this length here is 5. That was 5 right there, because we just counted out 1, 2, 3, 4, 5, so we know the hypotenuse. And then we know that it was 120 degrees, it was negative 360 plus a negative 120. So we went 360, and then here's 90 more of it. So that must mean that this here is 30 degrees, okay? So 30 plus 90 is 120, and then the 360 gave us a total of 480. But so this is 30 degrees right here. So what do I want to do? I want to use SOHCAHTOA, and so I'm going to start with sine. Sine of 30 equals opposite over hypotenuse. All right, here's my 30. Where's my opposite? Well, right across from here is my opposite, and we know that the horizontal axis here is x. This is y, by the way. So we're looking at x over 5. When I go to get this side here, by the way, it's going to be cosine of 30 degrees is the adjacent over the hypotenuse. And so that's going to be the y, because that's the adjacent side, over the hypotenuse, because that's what we were given for that, okay? And so what we have here is we have to multiply this side by 5 and this side by 5 for these to cancel, and you'll have to do the same thing when we get down here, okay? So sine of 30 times 5, 30 sine times 5 gives me 2.5. So that was the opposite, 2.5. And then the adjacent, which happens to be the y-axis, is going to be 30 cosine times 5. That's going to be 4.33. And this is going to be 4.33. Okay, so now I can come up here and I can plot it on my rectangular coordinates here, because this is 4.33 in this direction, 1, 2, 3, 4, and about a third. So I'm going to draw it lightly in here somewhere, 4 1/3, and I'm going to go negative 2.5 right here, 1, 2 1/2, and I'm going to put it like right about there, and that is my point B. So what is my vector? Remember, it starts at 0, and it heads in this direction right here, okay? And that would be the point where we're at for this, and it is 30 degrees right here, okay? And it was, we learned that it was a magnitude of 5 right there, but this side here was 2.5, and this side was 4.33. So that's just breaking down the rectangular components of of a polar point.